appreciate you taking time out of your schedule to join us this evening. I'm Ed Mullen. I'm the CIO at Think. Think is a company that's changing the world for the better by supplying organizations with technology and operational experts. I like to say we don't supply hardware or software. We supply grayware, highly experienced consultants who have a passion for guiding companies to the next level. I'd like to introduce Drew Hampton, research scientist and assistant professor at the University of Memphis. Andrew is an experienced researcher skilled in education technology, psycholinguistics, which I actually don't know what that is, but hopefully he'll explain, research design, and classroom instruction. He's got an MS and PhD focused on human factor psychology from Wright State, and is a postdoc research fellowship at the University of Memphis. Also on the panel tonight is Phil Horwitz, Chief Architect at JBS Custom Software Solutions. Phil, as he mentioned earlier, is a industry veteran with over 20 years in the biz. He's designed and developed systems in education, defense, healthcare, retail, financial services, just to name a few. Phil's currently the lead architect for an online educational publishing and digital learning platform for one of the largest nonprofit ed techs in the world. And you can take your guesses as to what that company is, or maybe Phil will let it slip during the conversation this evening. But with that, I will kick it over to Andrew.
Thank you very much. I'm very happy to be here. Thanks for the invitation. I will touch just a bit on psycholinguistics, not really the focus here today, but just want to encourage everyone, if you have any questions during the presentation, I don't mind interruptions. I'm used to being in a college classroom, so get plenty of those on a regular basis. But yeah, we'll go ahead and jump in. Okay, so I want to talk a bit about where the educational ecosystem is right now, where it's been, and why we have a real opportunity for a transformational change based on the research that's being done now and the technology that's kind of catching up all at the right time. So as a broad statement, we've heard this a lot, that COVID didn't break everything. It's just showing us where we already had our problems. And this has any number of applications, but it's very true for education. So we were just talking about how so many teachers are burnt out, or they're just not equipped. They haven't been trained to do this kind of distance education, certainly, because we've really been stuck in the same educational paradigm for the last 150 years. So this is very clearly a classroom. This picture is from, I don't know, 120 years ago or something, and you immediately recognize it, which is remarkable. Think about how rare it is that you could see a picture of something from 120 years ago and it looks the same as it does now. The hairstyle is about the biggest thing that's changed here. So we had been seeing, despite these advances in our understanding of how people learn, and despite our advances in computer-based instruction, that we were really doing the same kinds of things. So where we started to advance in computer-based instruction is, first of all, in mapping out what the domains looked like. So once you have a good understanding, a very regimented understanding of, say, algebra, you can make checkboxes. You can say we're able to we were instructing well on this and this and this, and you've gotten enough of the checkboxes that you can progress the students forward. And you can kind of translate that progress in California looks a lot like progress in Virginia. So we're able to have a much clearer understanding of what education means, of what we mean by saying someone's passed the 5th grade. They got an A in their high school algebra class. That sort of means the same thing, regardless of where you were coming up. And computer-based instruction allowed it, once we had that map made, allowed us to focus on individual instruction. That a whole classroom doesn't need to go over this topic just because 20% of them are struggling with it. Some of those students are going to be breezing right through this stuff, and we can give them more advanced material so that they can better spend their time. We're able to, at least in theory, have a more efficient learning process. But again, we're stuck in the classroom. We're not able to do that. One teacher has to handle 25 or 50 students at a time, and they can't have that kind of individual instruction. And going right along with our knowledge components is our mastery training. So that's just saying we've met a threshold. We're able to say they've passed whatever this is. And this foundational approach to computer-based instruction and to educational translation, I guess, in general, lets us do a lot of things that we build our education system on now, including standardized testing, admissions and evaluations of schools. And there's plenty of problems in that we won't get into, but we've built up the infrastructure, at least theoretically, around these ideas without translating it into how we're instructing our kids and our adults, for that matter. So then we move into adaptive instructional systems. So based on this understanding that we can map out domains of instruction, of education, and then understand on an individual level how a student is doing, what they're struggling with, we can take those basic ideas and really supercharge them if we have one-to-one, that is one student and one system, interacting. So that student, that learner, is able to see what's best for them on an individual basis. They can say, it can take more than just checking boxes. It can say, this is the kind of student that you are. You are a motivated struggler, for example, and maybe you'd like some more challenging problems, or you're somewhat unmotivated. So we need to build up your self-esteem. We need to make you feel good so that you keep engaging with the system. And you can do all kinds of really interesting things with motivation and engagement and optimizing, machine learning of what's the best path for the average student or this type of student. Someone mentioned moneyballing students earlier. So what is your doppelganger student? What worked best for them in the past? All these kinds of things that are now enabled by adaptive instructional systems. But there are problems with adaptive instructional systems as well. So one is that they struggle with specialization. By and large, these are made by relatively small teams. An adaptive instructional system might come out of a university or out of a particular ed tech company, and they will have something that they do really well. They had an idea, they ran with it, and it works really well for, I don't know, say teaching about how complex circuits work in electrical engineering. They give you a great dynamic visual, they can assess you really well, but it's really difficult to take that specialized approach and translate it to any other domain or any other level. It's a lot of development investment for a relatively small piece of real estate. They're doing something very well, but not integrated. And because of that, because they're very specific, they tend to have some trouble getting in front of a lot of students. And if you're not in front of a lot of students, then you don't have the same kind of power for machine learning, for optimization, and integrating the kind of AI at the scale that's possible, because it's a hard sell to get people to buy a system that is only going to do really one task. And this also lacks standards. So adaptive instructional systems are really in their infancy in terms of what we know that we can do versus what we're doing right now. And standards are one way that we can tell the consumers, the learners, the school systems, the ed tech companies that want to implement what it means to be an adaptive instructional system. And a big one is interoperability. So being able to plug a very specialized system into another system, or just be able to pass information and understand what that information means with respect to a different system or some kind of external standards, like your Common Core or whatever. And then how are we evaluating these things? What's the best way to do that? And of course, the ethical design and evaluation is inescapable and critical. We absolutely have to know what the ethical implications of these design features and implementations are. So just a quick plug that it's an IEEE standards group that I'm chairing, that we're working on all these things, and we welcome input from anybody who'd like to have an opinion voiced at the table. I'll hand it over to Phil here for a moment.
Thanks, Drew. So in practice and in our experience at JBS, based on some of these things that Andrew is speaking about, we've noticed this spectrum based on systems that we've worked on, and one that we're in the process, a large system that we're in the process of actually building ourselves for, as was noted, a very large nonprofit educational company. And on the left side of the slide, we have one side of the spectrum, and that is the adoptability. And that is systems that have very, very high rates of adoption, but have low adaptive features. And those are your typical LMS and CMSs and your classroom rostering systems and your standardized testing systems. On the right side of this slide, we have the other end of that spectrum, and those are systems that have increasing amounts of adaptivity features, but they don't have the adoption. And MOOCs are a special case where MOOCs are widely known. They have very high amounts of registered people taking these courses, but they have very low completion rates. So for the purposes of and intent of this discussion, that we consider that to be low adoption. And with that, Andrew's now going to show us an example of a system that he's currently working on that tries to balance both sides of that spectrum.
All right, thanks. Okay, so we have this issue. We know what we can do with adaptivity, but we struggle with getting it in front of a lot of people because of the specialization. So one approach to that is a project that I worked on called Electronics Tutor. And the idea here, this came out of the Office of Naval Research Grand STEM Challenge. And they said, okay, build the best electrical engineering intelligent tutoring system, kind of a synonym for adaptive instructional system. And instead of picking a winner, they said, okay, you 4 or 5 people, you all did a really good job. So put them all into the same system, put them all together. And I'm not sure if they understood the scope of that challenge, but it was quite a learning experience. So it was an effort to blend these, to get the specialization and the adaptivity, but without kind of pigeonholing yourself into a self-defeatingly small. All these different systems, this is great for formulaic practice, for plugging in and being able to solve kind of interpretations of that. These are constructed by teachers and are able to evaluate how predictive they are of student success. This is very difficult but holistic understanding, graphical representations of the circuits as they move. And then this point and query system, you just mouse over and it's going to, these are the most common questions that you would see. These are the answers. It really lowers the barrier to interacting with the system. So we had to throw all of these together into a single system. And the way we came up with it, we used knowledge components. So we break down all of these topics into different dimensions and identify all of them. So we had 15 topics, and then we said it's either a device or a circuit. And then it's either a structure, behavior, or function, or parameter. And then we multiply all that together, get 120 or so knowledge components, pieces. And then we could say, this question on this system is hitting this piece of information. And then we have a map, we have coordinates that we can translate progress on one system to progress on another system. We can say, we've covered this entire topic because we've gotten all of the component pieces of the knowledge that's necessary to understand it. So using that that initial computer-based instruction idea of mapping out the terrain, and then using that to advance our siloed or at least specialized adaptive instructional systems and allow them to talk to each other. And once they talk to each other, then you can have a much more powerful single system that's better for the learners. And this is what it looks like. And I'll just say it's smarter than it looks. we build prototypes. We're a university, not an ed tech company. So I'm quite certain most of the people on this call could make this look a lot better. But in any case, we have different kinds of adaptivity. So that we have instructor constrained. We can say the instructor is only letting you study this topic. So if you have a week on Ohm's and Kirchhoff's law, it'll move you through and make sure that you've reached a level of mastery that the instructor can set, versus anything that you've done in the system for the whole time that you've had your account is going to inform our learner model. And based on your whole history, we think that these are the most useful problems for you to interact with next. Or you can just let them go wild. Just say, this is everything we got, have fun, focus on whatever you think. And the teacher or the instructor can disable that if they want to have a little more control. But critically, whatever they pick is going to show up in the same place. So this looks to a user like a single learning environment. They're not bouncing around. They're not learning different interfaces. They're not having to sign into different places. All of this information, all of this interaction is presented as a single resource. And here's just a bit of information on how many levels of adaptivity we have. So a lot of systems will have step adaptive. You missed that part of the question, so let's do this. Or changing the problem, macro adaptive. Let's go to a different kind of problem to supplement this. But with our different kinds of systems, we're getting both higher and lower levels. We're able to not just change the problem, but change the entire approach, change the system that you're working in. And within some of those systems, you're getting much more specific. What kind of what kind of response is going to be most useful in adjusting this person's conception of the information? So we're able to show a lot more adaptivity, different levels of adaptivity, not just more problems, and it shows a lot of variability. And then as we're generating these recommendations, the critical component is a central learning record store. Everything they've done is going to one place, and we can draw information from that. And obviously, I'm hand waving here. Calculate performance is incredibly complex, just to put in a little box there. And then we're generating our possibilities based on a lot of different things, including constraints of the domain, so of electrical engineering in this case, and of the learner themselves. Are they a motivated struggler? Are they just trying to finish the topic, etc.? And then conflict resolution as you need, and generating those three items that just look like, hey, we think this is what you should do next. So the user doesn't have to understand the logic behind this. They just think, well, that's good. I needed something like that. So all of this to say, we have a lot of the groundwork laid. We understand conceptually how we can translate information. We've been doing it for our educational standards just at a static level. What does our SAT score mean is a basic example of that. But once we really incorporate computer-based instruction, which of course we've all been forced to do, we are forced to adapt, to change ourselves and our approach to instruction, which is an opportunity. So for all of their advancements, as I mentioned, the AISs have not currently leveraged collaboration. So they're still, for the most part, building siloed systems that have specialization. But now that we have forced fluency, we have people who spend all day on Zoom calls like we are now, or managing classrooms as teachers are doing now on Microsoft Teams or whatever. So they have a certain amount of fluency, the ones that have stayed in their jobs and persisted, and our hats are off to them. So now that we have this forced fluency and we have breakout rooms and whatever else, where individual learners or small groups of learners can have more tailored instruction, we have AI. We have natural language processing, so we can have relatively fluent interactions with artificial agents, and real-time avatars. So we can have kind of an embodied substitute for the instructor who's helping them move through their content, as well as the breakout rooms. So you can work in small groups, you can work with people, you can work with AIs, and you can build towards more constructive knowledge transmission, knowledge construction rather than knowledge transmission. So this is one example of how that could look. And I realize this is quite complicated, but if you just look at the green at the top, this is what the student would see in this kind of breakout room. So they prep for it, they choose an avatar. You know, we expect that a lot of kids there would be privacy concerns with kids learning. So an avatar gives them something fun and some anonymity. And you could go into a meeting room. Maybe you have an AI agent that's guiding you through it. Maybe a teacher is Wizard of Ozing it. Maybe the student doesn't know if they're talking to a teacher or to an AI. The teacher can step in, they can bounce from room to room, monitoring, but without kind of interrupting. And some functions to evaluate the system itself. Who was helpful? What were the functions of a particularly helpful collaborator? Giving feedback, letting them know how they're doing based on the lessons that we've learned. And of course, adding all of that information into their persistent learner model, letting the instructors or just the learner, if they're doing it independently, know what they're struggling with, what they're doing well, what they can do better. And then using that kind of AI and optimization, machine learning, what have you, to generate a recommendation, what they should do next, and tutorials that are kind of meta instruction on how you can be better in this situation. So what kind of authoring or group composition or all of these kinds of every one of these blocks is an opportunity for innovation, for some kind of, I have a great way to create tasks. I have a great authoring tool. In theory, all of these things could be plugged together from relatively independently produced software packages or software programs to create an ecosystem that is modularly expanding and improving and leveraging the affordances of our tendencies as humans, how we learn best. We're able to leverage that and move past finally the paradigm of an expert, a teacher, handing down information. You have to repeat it. Great, you've passed. So we can, because of this forced adoption of distance learning, we have the capacity to transformationally change our learning ecosystem. All of this, of course, is dependent on having some kind of computer-based instruction platform. So what would this look like? AI-moderated virtual classrooms is a relatively straightforward one move forward. Oh, I'm sorry, David, I see your hand is up.
Yeah, I'm trying to see if I want to interrupt now or I want you to keep going. I'm just thinking about this in my own classrooms, and I teach high school. And to be fair, I teach computer science to high schoolers. So I'm using every platform imaginable that I can to try and, in this time frame, connect to my students. And I appreciate that we have a lot more knowledge of how Zoom works. And but I also know my high schoolers and how they're reacting. And so far, there are a couple of concerns I have. One is, as an instructor, how do I get this data so I can read it? Because there's so much data going on here that already, like, I can't process, but your presentation is overwhelming. And then there's this little bit of this AI optimization magic. And I use the term magic not as an insult, but as if it's science, but I don't understand it. So it's some sort of magic going on. And there's a level of that going in this this space. And in that chart just before you're laying it out, all of these pieces, and I can hear, I realize that what I'm thinking is that the IEE committee that you're working on has to develop standards so all of these components can work together. But as a teacher today, I need something. Where am I in this conversation, right? Where does the teacher today fit into what's going on? Sorry for all of that.
No, that's fine. You raise a lot of really interesting questions. Granularity of information is a huge challenge. So how are we kind of cultivating this avalanche of information about your students or about a single student and giving you some kind of actionable information? Okay, I have all of this raw data. How do I convert it into something that's useful? And that's a very valid question. Some of the classroom management or learning management systems can give you an idea of that at the level that we have now, which is just You can analyze on quizzes that you administer which questions people got wrong, kind of in the aggregate. So you're not just sort of, okay, I think I remember putting a red X through number 3 more often than anything else, so I should cover that. So having that kind of really basic level of feedback and information as a teacher in my classes is certainly useful. But taking that to the next couple levels is what this would enable. How you integrate that into your system is, into your instruction, is very much an open question. A lot of this would be done automatically. So the recommendations generated by the system would be continually optimized to give, say, in this particular circumstance, this is the thing that we should offer next. And it bypasses the teacher to a degree. How to kind of generate classroom level progress reports is a really interesting challenge that I'm actually starting to work on. It's a bit hard with just a theoretical setup, though. We might have more luck in this discussion with a broader...
You're welcome to come into my classroom anytime you want. Baltimore City, just come on down. We'll see what we can set up. Instead of being in the theory, let's go be in practice and figure out. My concern there with that automated system is that level of trust that I was talking about a little bit before. The same thing with the MOOCs. People understand 150 years of education and how it works and what we know. This stuff they look at and they say, I don't understand. You mean you're gonna ask a harder question because they got this one wrong? You're gonna ask an easier question because they got that one wrong? And intellectually, on one level, they understand that, but on another, they don't have the trust because they can't convert it. So there's that whole level of trust in order for me to get my district to buy in onto it.
Yeah,
but you're welcome to work with me in my class.
No, I'm very much trying to get more of these systems in front of students so we can really evaluate them and work with the instructors. And that's a critical component that I forgot to mention, is working with the instructors, not trying to cut them out, because you have expertise. You have more than just classroom management. You have insight into the content and how young people learn that we want to leverage. So yes, that's very important. Trust and automation is huge, and there's whole conferences dedicated to trust and automation, and also what's sometimes called scrutability. So is the end user able to understand the logic that was applied by the AI? And that's another whole field of research. So you're raising a lot of interesting questions that I don't have the bandwidth to address right now, but thank you very much for your question. Just to jump into a couple more use cases. So we've been working with a Chinese company, and apparently in parks in China, they'll have English corners set up, which are just designated places where people want to practice their English. Put that in one of these systems. They could talk about any number of things. We could have varying levels of moderation to get people feedback on how well they're communicating, how well they're problem solving, kind of applied language learning. Sorry. Anti-racism training. So we have a researcher at University of Memphis. She's the former head of the American Psychological Association. She wants to leverage this ability to disguise the users, the young people, and then experiment on how people react, how we can not just, color blindness is not the goal here. It's intentional approaches to how we're seeing and responding to race. So it's really interesting stuff. Model UN is a consensus building, finding solutions to complex problems would be very amenable to this approach as well. And then just generally structured team problem solving, giving them a problem and letting them, helping them stay within the bounds toward a productive and constructive solution. As well as after action reviews. So these are typically military, but a lot of corporations or whoever else does them. After you have some kind of engagement or exercise, it's a very regimented way of analyzing and evaluating it, which lends itself well to a structured approach. So just to bring it kind of back to the higher level, that adaptive instructional systems, this provides a groundwork. It's an opportunity for transformational change, for taking us to a level of reliable and adaptive and individualized instruction that can move us forward in some really innovative and fascinating ways. But remembering that innovation is wasted without integration. So you could have the greatest system in the world, but if it is only playing in its own sandbox, if it's not able to talk to any other system, then it's going to be wasted. It's not going to be adopted certainly widely or to the level that it deserves by virtue of its contribution. So I'll hand it back over to Phil.
Thanks, Drew. So Drew covered quite a bit of the theoretical aspects of the kinds of things that we're starting to see in adaptive information systems and some of the challenges in terms of standards and things like that. And what I'm going to speak briefly is to some of the tools that we can use to help build and implement some of this functionality that Drew has been discussing. And we're going to focus on three particular tools: AWS Comprehend, AWS Lex, and AWS SageMaker. And these three particular tools have been chosen because A, for their space, they are some of the most mature tools out there, and B, they allow us to lower the barrier in some cases tremendously to adopt some of this adaptability functionality and to incorporate that into new or existing systems that we are building. So AWS Comprehend, and what is AWS Comprehend? It's a fully managed natural language processing platform. And what that means is that essentially, based on text passages, whether they're a single sentence or whether they're a far larger document, it gives this service the ability to recognize portions of that text, whether they be key phrases, personal information, or tone and mood that the writer has conveyed, which in our parlance is called sentiment. And in terms of how it works, it essentially, and if you're familiar, for those of you who are familiar with more machine learning based technologies, there's essentially a training aspect where the algorithms involved continuously look at data, and then they use that data to train, and that is the quote unquote the learning and the machine learning. And so AWS Comprehend is continuously trained, and one of the nice things is that it's something that Amazon does for you, and that's actually a huge benefit because for those of you that might have been involved in any kind of machine learning projects, the actual training of your model is the aspect that probably takes proportionally the longest out of all the other aspects of a typical machine learning project. So you don't have to train this service. It handles all that for you. And then once you have it deployed into your own system, it can help allow you to determine what kinds of actions you want to perform based on things like key phrase detection and sentiment. And our next service that I'll give a very brief overview of is Lex. And essentially Lex is an AWS managed service for creating intelligent agents and chatbots. And a large part of this technology is automatic speech recognition and natural language understanding. And it's the AWS Lex service, it uses the same technology as Amazon's Alexa does. So it's actually, for the amount of time that it's actually been released and in production, it has a higher level of maturity than many other services like this, because Alexa, there's hundreds of thousands or maybe millions at this point of Alexa devices in service throughout homes, offices, classrooms, and so on. And it's allowed them to continuously fine-tune this technology. And essentially how Lex works, excuse me, is you create a bot, and then what you do is you provide intents for this bot. And intents are essentially pieces of functionality that you can allow the bot to perform based on audio or written responses And in the AWS vocabulary, they're called sample utterances, but they could be questions or statements, whether oral or oral. And it allows you to program or build from functionality that comes out of the box, responses and actions. And the nice thing about Lex is that once you publish one of these bots, you can immediately integrate it into your own systems. And out of the box, it also allows for integration into things like Slack and Facebook Messenger. And the final service that I'm going to give, again, a very high level overview of is Amazon SageMaker. SageMaker is Amazon's fully managed machine learning service, and it's a general purpose service. It's for working with a wide variety of problems such as classification, prediction, segmentation, and forecasting, to name a few different kinds of problems that you use SageMaker for. At this point now, over the years, SageMaker now has become, it's an umbrella service for many, many other related services that fall under the SageMaker moniker, such as Studio and AWS Data Brew and other things that allow you to incorporate machine learning models into your services and systems in a much easier, much pain-free fashion than before. And essentially how SageMaker works is it's kind of the canonical machine learning list of steps, right? You have a data preparation phase where you're gathering data for ingestion, transforming it, cleaning it, prepping it. Then you have your model selection and your training phase, which, as I mentioned, is where you're going to spend the majority of your time in this set of steps. Then you have your testing and evaluation and your deployment. And then you enter this cycle where you go back, you acquire more data, train your model again, test it, eval it, deploy it, monitor it, tune it, and so on and so forth. And the benefits of these services are that really they help lower the barrier to entry. But one important one is that they automatically scale and provision compute capacity as needed. So whether you have one school or one university, or whether you have hundreds of thousands of schools, they will automatically scale for you, and they will help cut out a lot of the operational overhead if you were managing some of these services yourself. Another important aspect that they provide is automated workflows. So a lot of these services, they integrate with other services such as AWS CloudWatch and CloudTrail, which are reporting, monitoring, and logging and auditing services respectively. So you can get the data that these systems are processing and the outgoing results in logs and reports, and they're monitored, and all that is done for you. And another important thing is that they're secure and encrypted. So the data at rest, whether it's sitting in a database or sitting in a service like Amazon S3, it's encrypted. And when data goes over the wire, such as when you're sending information from your system to a SageMaker endpoint, it's done via HTTPS, and it's secure sockets layer encrypted. And of course, as I mentioned in one of the subsequent bullet points, these easily integrate into other AWS services, such as the monitoring services and the logging services and auditing services. So if there's operational aspects of the systems that you need to be heavily involved in, the alerts can be sent out, and you can be, the overall health of what these services are doing is very visible and very transparent. And it's also, these three particular services, they're out there and they're being used. And for these kinds of, this kind of functionality that Andrew's talking about is going to become increasingly more common as we move forward in time. And these solutions are here, they're very pragmatic ways to build this kind of functionality into your own systems, whether they're new efforts and greenfield in application, or whether they're existing and legacy applications. So a really important question is, these services sound great, but how do I incorporate them into my system? How do they integrate with work or systems that I may already have? And the integration of these systems is actually very, very straightforward for the kinds of functionality that they offer. And one of the most important ways you can integrate these systems is through AWS's provided SDKs, or software development kits. And they're offered in multiple programming languages, very, very common ones such as Python and Java and JavaScript. So they're very available, and they're very easy to incorporate and adopt into your own systems. And many of these services, such as SageMaker, for example, they provide REST-based SSL endpoints that any of your systems can call out to and pass in the information they need, such as, for example, if it's AWS Comprehend, you can easily call an endpoint, pass in the data that you would like it to examine, and then get the results back. And we'll have an example of something very similar like that. So for the more technically minded of you, here's a very quick example of code of what this would actually look like in a programming language called Python. And within 4 lines of code, of which the first, Boto 3, is the AWS official software development kit. So we're telling our code we want to use the AWS software development kit. And then our next line, we essentially tell AWS, hey, we want to talk to AWS Comprehend. Our third line of code that we have is essentially, that could be input from your system, and it could be a student essay, it could be a test answer, variety of things. And then our fourth and final line of code is we're asking our Comprehend service now to detect the sentiment of that potential response, and we capture the result. So not to get too technical, but hopefully this example for the more technically minded among us can it shows very briefly how relatively straight ahead it is to incorporate some of these things into our existing systems and code bases. So from a summary standpoint, there's a lot of changes that are going to be coming up. And I think that they're probably going to be coming up sooner than we would think. But I think Andrew brought up a fantastic point, especially as the guy chairing the IEEE committee for a lot of this, is that there's a lot of things that are still in flux. It's still very dynamic when it comes to standards, especially for things like interoperability and various kinds of communication protocols and data formats and so on. However, with that said, we do know in the last couple of services and software functions that I just went through very briefly, we know those kinds of techniques that are going to be used, whether they're conversational interfaces or other functionality that allow us to create a more engaging and interactive experience in the classroom from an electronic standpoint. And the tools and technology, they're here. And in many cases, some of them are mature and they're readily available to be used in our own solutions that we're building. And I think for those of us who are working on these kinds of systems and who are building these kinds of systems, I think it's important that we take a very hard look at some of these kinds of concepts and technologies that Andrew spoke about earlier and see how we can get started to incorporate them into our own solutions.
So I suppose we'll open the floor for any questions.
Hi, David Cross here. So you talk about collaboration, and I guess what I see in the companies that we've worked with in the past, they are fairly all specialized. They've all seen a fairly, I don't want to say simple problem, but a very defined problem to solve. So how do you see them taking that into this broader collaboration and the whole AI in this broader collaboration for those? I know how to do a math issue, or I know how to do a vocabulary, or so how do you what do you see as happening to those companies and what they need to do to make all this happen?
So there's, I guess there's two ways to answer that. One is kind of, they're going to do it because they have to. I mean, there's no alternative. If they keep building siloed systems, they're going to get left behind. What that looks like in terms of, they've decided they want to collaborate with people. How do they go about it? That is definitely one of the questions that's in flux. How are we going to see this coming together? We know that it's going to come together, but what's the mechanism of it? I'm very interested to see that. And I'm working on the IEEE group to a large extent because I'm trying to facilitate that process through interoperability and evaluation, conceptual modeling, all of these things. I have a lot of industry people in the room when we're talking about it, and there is no kind of plotted path forward. They all recognize it's something they need to do. And sometimes it's a university making a prototype for how we can do this, the kind of project that I illustrated. But that's, we're a university, we make prototypes. It's not a finished system.
So just to follow up, are the LMSs the real key to this? Since they're kind of the backbone of what most institutions, schools are using, or are they really the key to getting that collaboration and interoperability?
That's a great question. I would say the key is more a learning record store. So not a learning management system, which is the platform. Many of them are explicitly built not to do this kind of stuff. One of our iterations of electronics tutor, we put it on Moodle, and more or less we just had to build our system and then send it tiny packets of information to Moodle, and then kind of hack Moodle to be able to look like it's doing the things that our system is doing. And it drove our lead developer crazy because he found all this documentation from Moodle that says we are not designed to do this. So he really had to break it in order to make it look like it was as smart as our system was on the outside. So to the extent that they're willing to restructure their architecture, yeah, they're in a great position because they're in front of so many student faces. But if they're willing to do that is again, an open question.
Right.
So, this is Dave Robson. The system that you described was, I believe, designed for the Navy electronics. Is that currently being used in the Navy?
We are working with the acronyms are terrible. The Naval Nuclear Propulsion Training Command to upgrade their systems, and by upgrade I mean literally paper and pencil is all that they're using. They've had a lot of problems moving forward because a lot of their training is classified, but just getting kind of this basic general electrical engineering knowledge to them through something that's helping the teachers out and giving more adaptive instruction. So yes, we're working with them right now to implement it in the classrooms, in the schoolhouses, not in front of students at this moment, though it has been in the past and it will be in the near future.
So it's been tested with naval students. Is that pilot situation?
Pilot, yes.
And what was the completion rate?
So it wasn't independent. The instructors would assign work, so they didn't get to drop out like you would in a MOOC.
Do you have any idea what the overall throughput rate is? I'm thinking, let's say a young person applies to join the Navy and some fraction of them are rejected. And then the accepted ones might apply for electronics, and some fraction of the applicants are rejected, and some fraction of them make it through. And you have any idea how those ratios pan out? Is that of interest to the Navy?
Right. Yeah, and not well for their existing system. That's one of the reasons they approached us was they are taking the sailors who score the highest on their entrance exams. These are like 97 percentile and up are the only ones that get to go. And then they have a ton of them failing out of this basic electrical engineering. So they wanted to have some different kinds of remediation. So we were, in our pilot, we're working with remedial students who otherwise would have failed, but were kind of being given another chance on this new system. So I don't have kind of an apples to apples comparison because we're already dealing with a subpopulation.
Right. Does the Navy have any interest in how they retain this knowledge a year or two later?
Yeah, actually, so a related system was called the Personal Assistant for Lifelong Learning. Several of the components were just plug and play from that to this. And we did exactly that. We tested knowledge decay over a 6-month time frame. And we saw, even with just, we didn't make them use it, we just made it available to them. And knowledge decay froze. It dropped away. And if you look really closely at the data, you can see that the sailors who used it actually got much better in their proficiencies. But not even accounting for that, taking all the people who looked at it once for an hour when we were training on it and then set it down for 6 months, lumping those all together, we saw no significant decrease in knowledge over a 6-month period. So we're definitely seeing effectiveness in retention of this knowledge, especially because a lot of times they'll get out of A school, their basic training, and they won't get to a C school assignment for 6 or 9 months. They're just, in some cases, literally sweeping floors in northern Illinois for 6 months.
So what do you see as the big obstacles to adoption of these technologies? Or maybe you could answer the question of, in a perfect world, what would you be seeing, 1, 2, 5 years out relative to these systems?
Right. So the biggest hurdle, I think, is just institutional inertia. It's a big investment. It's retraining teachers. It's making sure that students have reliable access to not just computers, but internet, which is not a given in a lot of the country. So convincing schools and teachers that this will make their lives easier on top of, adopting a more theoretically sound model of teaching. So knowledge construction is much more resilient. It's much more transferable. It's much more engaging than knowledge transmission. But making that leap is not easy. Where we would be in 3 to 5 years out is moving beyond kind of our current state of learning management systems, so we can track progress on quizzes and getting the understanding into our learners and our teachers and our administrators that adaptivity is your friend, that you can make these classes more efficient, more engaging by virtue of incorporating some of these cutting edge technologies. And as those kind of start to trickle in, which is I'm sure how it will happen, it's not going to be a wholesale transition. Just David mentioned trust in automation. That's a huge issue. Getting teachers to think, to understand that we're trying to help, one, that we are helping, two, and that this is something that they can do. A lot of these instructors have been teaching the same courses for 40 years, and they're telling them, okay, we need to change everything you're doing. That's a hard sell. So yeah, there's a lot of challenges, but the upside is exponential.
Hi, my name's Tammy. I'm with EBSCO Learning Express. Some of what you're saying I agree with, but I've been in this industry for a very long time, and I know there are very, very successful revenue-generating adaptive learning products out in the K-12 space, including Pearson's SuccessMaker, including Scholastic's, and now Houghton Mifflin's Read 180 and Math 180. And so there are plenty of school districts and teachers out there that have already embraced and accepted individualized, personalized instruction on those products. You can add to that Apex Learning and Plato Learning and several others that have already been out there. Now, granted, they may not be using the most sophisticated of AI right now, but these programs have years, decades of efficacy based on item analysis and data gathering. And so I'm not 100% sure I agree with this. And there's not too many, there's a lot of educators using these products. I just looked it up. Read 180 is still a $300 million product, which means there are a lot of school districts out there that have already embraced that adaptivity to teach reading in this country. What I'm a little concerned about, though, but what I'm intrigued about is the conversation, not concerned so much as intrigued, which was why I joined the conversation, is you're right. They are looking at very specific domains with very specific niche algorithms to do what they're doing, and to be able to explore a way to find a way to extend that would be to a company like EBSCO, where we have a huge breadth and depth of content. You name it, we have it. And so to be able to apply something where we didn't have to have a very specific reading, math, science, career, that would be very intriguing. I'm also intrigued by the notion of the collaboration, although my experience has told me, and it's getting worse, well, it's getting better, but it's getting worse, is the notion of privacy concerns. The privacy concerns when you start talking about collaboration, sharing data with multiple institutions that you're collecting on your side. You have FERPA, you have COPA, you have GDPR, you have California's very strict standards, you have Texas coming out with very strict standards. And so I think it really behooves us all as we think about this, as we, obviously EBSCO is looking at this. We obviously have an AI team. It's very important, although I think it's wonderful. And I liked your understanding of the avatar and the ability that one slide was very intriguing. But I think we all have to remember that while we embark down this journey, we have to be aware that the law and the privacy concerns are going to be right there on our backs as we do this.
Yeah.
And thank you very much. Very intriguing. Very, very much. I'm Tammy Cunningham. I'm the Vice President of Development at EBSCO Learning Express.
It's very nice to meet you, and thank you for raising those points. My inclination, and I probably should have said this earlier, I tend to think about higher education at high school and beyond. So adoption at lower level, at K through 8, let's say, is quite a bit higher. And primarily, it's easier to map those domains.
Of course it is, because there's lots of metadata.
Right. The data privacy thing, you're absolutely right, is a huge concern. And there's always the possibility that the government just pulls the rug out from under us. We're worried about it. Yeah, it has. And there's a lot of good work being done on data anonymization. So being able to reliably take the central features of the data, so the important features of the data for optimization, for testing theories, for understanding the functions, the mechanisms of learning, without having anything that's remotely identifiable at an individual level, or even at a school district level. So theoretically, if you can say all kids in Little Rock 8th grade have this characteristic, that's a privacy concern. So being able to recognize the different levels of anonymization that are necessary now, or that very well could become necessary, is a critical concern that has the potential to just wreck a lot of efforts. That said, I don't think it's an intractable problem. I think that we are keeping pace pretty well with our ability to anonymize and to protect data at an individual level, at a school district level, whatever else. Yeah, we're keeping a close eye on it, though. Thank you.
But that is also, I think somebody else had brought up the question about trust, right? We all as technologists know what we can do to protect data. The question is, do they trust that what we're saying we're doing it? And that's where the legislation usually comes in, is that they want us to be able to 100 absolutely be able to, for example, let somebody completely delete or eradicate their account.
Yeah, and it's very scary for me when I saw, the CEO of Google testifying before Congress, and they're asking him about their iPhone. Like they don't know the difference between Apple and Google, and they're the ones making the laws here. So it's scary how little technological sophistication the people making the rules actually have. I don't have a solution for that. Just scary.
Every day. But thank you very much. I appreciated your presentation very much. Thank you.
Thank you.
There was a question from David Cantor. He asked, what is the development time for one of these programs?
Oh boy. How much money do you have? That's the only way that I can answer that question is, in technology, it's not usually, is this possible? It's how much is this going to cost? So the electronics tutor program, that was, let's see, the individual component programs, I think was an 18-month, and then putting them all together was another 18 months. So we're looking at 3 years for that. And then you got into implementation and testing. That's a few $1 million for a relatively ambitious program. So if you had, say, 50, you could do it a lot quicker. But yeah, it's really hard to say.
But doesn't that go right to the idea of practicality and ultimate value? If it's so expensive to develop, how, that I'm guessing that's part of your committee is trying to figure out how to make standards so that it's less expensive. But where's, it's got to come down to some level. I mean, I know AWS is awesome and it's got a lot of tools that I can bring into my classroom, but without some way to do the tracking you're describing, it makes it very hard for me to know what my students are learning and to engage them on that next level. Right? Because I have a lot of students who sit there and they get the surface level, but there are a few in there. There are a few crumbs in there that really can go forward. But I need that tracking system you're tantalizing me with.
Yeah. So being able to differentiate performance on tools that are correlated with conceptual understanding versus formulaic fluency or whatever else. We would very much want to have that, and something like electronics tutor would be able to differentiate. But in terms of how can we get this in front of our students quicker, I was too flippant with the how much money do you have. There are a lot of innovative approaches. So for example, the auto tutor questions, that takes a lot of authoring time. But one of my colleagues, Professor Andrew Olney, he came up with this system to automatically extract from textbooks key questions. And it's not very good. It's okay. You can get a question in front, and a lot of times it's going to make sense. But what he found out was if you put that in front of students and have them evaluate the questions, and they'll get better iteratively, the students who are doing the evaluating will get better at the content. And in fact, they'll get better than if they were just given a textbook to read it. So that tool to improve the authoring system, the automatic authoring system, is itself an adaptive instructional system. So kind of bootstrapping these ideas or daisy chaining, I guess. And that's one example, but it's an example of how much innovation is going into particularly lowering the cost of adaptive development. Authoring tools are a huge area of research. How can we make this easier? How can we lower authoring tools to the level that a medium sophisticated teacher would be able to do it themselves, so they can have custom content and what kind of adaptivity is possible? So these are all open questions that are actively being investigated by me and a lot of other people.
Yeah. My opinion on the authoring tool side is, yes, we can all create authoring tools for our proprietary content. The thing that makes authoring tools so difficult to put out into public space is that questions need to have metadata. And if you don't understand metadata and you don't understand how to input the metadata when you create, it's easy enough to say, here's the distractor, here's the stimuli, here's the question. It's harder to create the metadata around that content. And that's one of the reasons I've seen very few good authoring, public-facing authoring tools. I know, a lot of people know how to use WordPress and they know how to use LearnDash, but when you look at those products, you also realize that the content that's being input into those systems is of relatively little use in this world, because a lot of what a teacher would need to be schooled on is how to create metadata, the correct metadata question, not just the question, but what's the metadata.
Yeah. So one approach to that.
We've thought about it many times about how could we turn out because we obviously have authoring tools to create our own content. We've thought about it many times at how would we successfully create a tool that would allow customers, forget third parties, customers to actually add their own content to the content management system and then use the assessment engines and all the rich applications that it can be applied to. And it always comes down to it's expensive to create that kind of UI, UX that would make it relatively easy for a layperson to understand what is involved in the creation of a question.
Yeah, you're absolutely right there. One approach to generating metadata, not to authoring metadata, but to generating it, is to turn to crowdsourcing. So as people are interacting with these questions that have been produced by not technical experts, by domain experts, but not technical experts, is to have some kind of tagging system, some kind of voting system for, does this cover this particular topic? And then the other kinds of metadata, like how long is it taking to interact? So you can get difficulty measures and those kind of things to have information about the questions. Right.
Or the things, that of course EBSCO does very well is metadata and indexing of all of vast collections of databases. And a lot of it is there's a lot of open source taxonomic libraries out there, but it takes a fair amount of expertise to understand how to use those. And we would not expect a classroom teacher, even at the higher ed level, to be able to or want to, like they have a day job. Right. If they want to start creating content, they should just come work for us and leave the classroom, right? Because it's an enormous undertaking. But I think, the other thing that you reminded me of was when I started my career as an advanced placement biology and chemistry teacher years ago. And one of the things that I used to do with my students back in the 90s, if you recall, I'm aging myself here, but there were big controversies around textbook corrections and of inaccuracies in textbooks, particularly science textbooks and history textbooks. So I used to give extra points to my AP students if they looked at the other biology and chemistry textbooks and found errors. And if they could demonstrate to me that they found an error in the book and they could explain the error, I would give them extra points. You'd be surprised, in the 7 years that I taught in the classroom, my students came up with a lot of errors and a lot of textbooks from a lot of different publishers.
Evaluation.
But if the student could figure out the error, they'll never forget that. That's something they'll go away with for the rest of their lives. They will always remember that.
Yeah, great idea.
So I do like the way you structured, what did I do wrong? How did I come to the solution? How do I correct that? Yeah, very interesting. Very interesting.
Okay. We're coming up on the end of our program, but what I'd like to do, to wrap up is, first of all, to thank Drew and Phil tremendously, and for the amazing Laura France for coordinating and pulling together this event, and also to do a request for future topics. If there's something, I'll throw my LinkedIn profile in the chat box. But if there's a topic you wish that we could find somebody to speak on, or something that you want to speak on, let us know. We're looking to have a community-driven, series of presentations and meetings. And for those that weren't on when I talked at the beginning, we have one planned for March 23rd, potential of EdTech meeting on the impact of VR and AR in the education community. And it'll be a panel discussion. So some major experts with experience rolling these things out, both corporately and in the academic space, we'll be talking about what they see coming in future years.
I really appreciated what Phil had in terms of his brief descriptions about the AWS technologies. And that is there's an area that our teams are working on right now. And a couple of my team members are actually on this call. They're staying quiet because they know I'm gonna say this. We're working on a POC right now with some of the technologies, and it's not ready at this point, but at some point down the road, if people are interested in looking at some of the work that we're trying to do with the AWS technologies, we would be more than happy to go a little bit deeper dive. It'll be several months from now, but I think that we would be happy to share some of the thoughts that Learning Express has around those areas.
Very good. So
Thank you, Tammy.
I always love a show and tell from the community members. And I think we'll be doing stuff like that, especially for the startups, sort of doing an event sometime next quarter that's like a fast pitch, or, getting like a half dozen, startup ed tech companies to real quick tell what they're doing, and, maybe get some feedback or some, technical opinions from the development side of the equation. Try to do some matchmaking between the idea folks and the academic folks and the geek folks, which I would throw myself in that category.
I think we're pretty geeky ourselves.
It does seem that way. And what's kind of interesting in my network, because I do all this competitive robotics stuff in Baltimore City schools, I meet a ton of the comm sci teachers and the tech ed teachers. And that's where things really get interesting, because they start building their own stuff. So
I just wanted to, I made a mistake in the chat. Potential of a tech panel discussion on AR/VR is actually happening on April 20th at 6:30 p.m. Eastern time. So we can invite everyone that's on this call to that event as well.
Very excited about it. So have a good evening, folks, and thanks for coming. And if you have questions or comments later on, feel free to give us a jingle.
Thanks a lot, everybody.
Thank you, everyone. Have a nice evening.